Hello, once more, welcome back to the desk. Last video I noted I was going to be showing how to use this little display screen here. Built the ESP32 boards I'm using got built in. That's actually going to come later. There's a little project I'm building up to. So in this video, instead, we're going to look at connecting a direct read sensor to the ESP32. Specifically this black thing here. Stay tuned. Okay, so what's a direct read sensor? Oh, this is one. By direct read, I mean we've got a sensor and we will be directly reading its output to do something with it. This board can also perform a little bit of processing, give a processed result. So what we're going to get off this is an analog reading from the sensor, and this board can also give you a digital reading that says is that above or below a certain value. So depending on what you want to do, you've got options on both of them. But what is this? Well, this is marketed as a flame sensor. Now, while I'm very sensibly not allowed to play with fire, not anymore, not after last time, it's still useful because it's not actually a flame sensor. What it is an infrared light sensor. Now, there's a few bits to this, such as the little LEDs, which are down here, these two little LEDs down at the bottom. We've got a couple of resistors there, a couple more resistors at the top. Little brown things are capacitors. This is a variable resistor, which is used to set a threshold value. This little thing here is called a comparator. What that does is compare the output of the sensor with the reference value and say above it or below it. Yay! But what's this bit? It looks like an LED, but it isn't. And we have a look at the circuit we've got here. See, this represents the circuit we've got. Now, the thing labelled photo NPN is this black thing we've got. It is an NPN transistor, and it reacts to light. The black plastic colour filters out other light, transparent to infrared. Takes that light and decides how much to turn it on. This is the magic of a thing called a semiconductor. Most things conduct to some level. They either do it very well or they tend to do it very badly. Transistors are semiconductors, as they conduct but in a slightly more controlled way. So what we have is the symbol for a transistor, and this is a normal transistor. NPN is the type. There's two types. One is NPN, the other is PNP. We're only going to look at the NPN one here. This has got 3 pins, a collector and an emitter, which is, if you think of that as a piece of wire that might conduct electricity. And we have there is another pin there called base, and this is where you control what happens. And what we do, you put a little bit of current into the base, and you can switch a much larger current between the collector and the emitter. So, yeah, but it is current driven. This is not voltage driven, it is current driven. There is a voltage driven version of this called a field effect transistor. We're not going anywhere near those. So, in the last video, where we were looking at the relays, what we did is we used a transistor to use a small current from the microcontroller to switch a big current that could drive the transistor. It works quite nicely. What we have here, let's go back to the beginning. This transistor works in a similar way, but it doesn't have the base. Instead, it reacts to light. So, if we go back to this here, what we're essentially going to do is shine a light at that. It's fairly straightforward, but infrared light. You think, well, why would we want to do that? Sometimes you want a light source, but you don't want to be able to see it. So, yeah. And what this is going to do, this is going to provide an output on this analog pin, whichever one it is. Yeah, well, one of them. And that'll be between the supply voltage, which will be 3.3 volts, and 0. And if it can see light, because if we go back to the little circuit diagram here, if it can't see any light, the transistor is off. This means this output up here, labelled A0, is effectively connected to the supply voltage. So it'll be 3.3 volts here because we're using that. Ignore the resistor. If this transistor is not conducting, it may as well not be here. There you go. If this thing, on the other hand, sees a lot of infrared light, this transistor will turn on fully. And in effect, what happens is then this pin A0 is connected to ground. So you'll get a very low reading. Not necessarily zero, you'll get a very low reading. There will still be a little bit of current splitting. And that's the only bit we're going to look at to start with. Ignore the rest of this. Ignore all the other little LEDs and what have you. So, yeah. That's what we've got there. So, what we need to do is hook this up on the board and see how it works. So, let's get on with that. And here's the sensor connected to the board. I'm just going to try and find a little bit of wire I can use as a pointing stick. I have a pointing stick. I shall use the pointing stick instead. I can pick it up. So this is a board. It's just been shoved into breadboard. What we've got down here, this wire on the end is 3.3 volt. The one next to it is ground. We've then got two sensor wires. One gives us the analog signal, one gives the digital signal. The green is the analog and I think the blue is the digital. Sensor sits here. What I've also added is this little blue resistor, which is a 120 ohm resistor, and it's connected to this. This is an infrared LED. When we power it on, it's interesting. I won't be able to see it, but you will, because this camera will pick up infrared. So what we need to do is power it up. Now, the other LEDs use quite high resistors. The ones over here are using 1K resistors. These are using 330s. So why is this using a 120? Well, to get a good bit of light from an infrared LED, you do need a bit more current through it. Most LEDs, when they say they want 20 milliamps, they'll work on 2, 3, 4 quite happily. Infrared want between 20 and 40 to get good output. So I'm going to have about 27 milliamps here using 120 ohm resistor. I was going to use 100 ohm, but I found the 120s first, so there we go. So what I'm going to do is I'm going to power this on. Now, we're going to see what we can do with this. And then I'm going to add a little bit of code to it, and we'll get on with that. So as it stands, this is doing what it did previously. Now, you see what I mean about you can see the glow? I can't see that, that's off as far as I'm concerned, but to the camera that looks like a white LED. We have a little red LED on this board down here, which is showing it's powered. So, have a little look at the code and we'll see what we can do with this thing, because it's a little bit different. So this is basically the code as we left it last time. This is off the relay video. We need to do a few little changes to this. So the first thing I'm going to do is I'm going to add some definitions up here. So we're going to start off. I'm just going to move a wire first, because as usual it's sitting on my keyboard, which is slightly annoying. Just excuse that one. We're going to put in there, it says the sensor, the digital out is connected to pin 26, and the sensor analog out is connected to pin 25. And that means the board now knows where we're looking. What we also need to do is tell it these two pins are inputs. I'll sort the spacing out on that in a second. So there we go, like that. And that triggers me slightly, so I'm just going to do that to bring them back. So we've now told it where these are, and we've said these both need to be inputs. And to start with, I'm not actually going to do a great deal with the code in here. There's all the existing code is there, and I'm going to come down to here, to just above where we've got the read buttons, and what we're going to do is we're going to read these two sensors. Now this uses a command we've not used before, so let's have a little look at this. The command analog read. Now digital read we've seen before when we did this, the buttons. That will return either a true or a false, a 1 or a 0 based on the sensor. So what does analog read do? Well, we can't actually read an analog value. Now, by analog, what I mean is it's a voltage. It'll be between 0 and 3.3, and we're not going to get a value back that says 0, 0.01, 0.0001, or anything like that. What we've got inside this little beast up here is something called an analog to digital converter. This is another area where this differs slightly from the Arduino. The Arduino has what's called a 10-bit analog to digital converter. You'll get a value back between 0 and 1024, depending on what you've got. In the Arduino's case, it's a 5-volt system, so 0 is 0 and 5 volts is 1023. That's just how it works. It's a 1024 range, but it starts at 0. Here we've got a slightly better analog to digital converter, and we're going to get back a value between 0 and 4095. It's just a little bit more granularity available, a bit more detail. There are occasions where you might need a 16-bit analog to digital converter, and you can get external boards that can do that. If, for example, you're doing current sensing to try and do block occupancy detection on your own, you'll find these 12-bit ones won't be good enough. You'll need the 16-bit. So, there we go. And what happens here, we tell this thing, do an analog read, and it will store in this 16-bit value. We're not going to use all 16 bits. We're only going to use the lower 12 bits. The upper 4 will always be 0, but that's fine. Doesn't matter. We're going to read that, we're going to store it in there. Now, sometimes also with the Arduino, if you want to read, let's say, 6 of these things, one after the other, you need to put a very slight delay in between them while it sort of switches between one and the next. Usually what I do with that is you read one value, do something with it, then read the next, and do something with that, and that's easily enough. But that's that. We've now read our little values. But we need to do something with them. And to do something with them, I'm going to print them out. And because I don't want a whole stream of numbers shooting past, what I'm going to do is this. Now, this means I need to go up to the top and I need to add a couple more variables, which we shall find where I've put them, and I shall put them in. So we're going to put these up here. And these are more timing values. So T last print is when did we last print the values. And we have T print period, T for time, it just makes it a little bit easier to see this value storing time. 1000 milliseconds, so every second we want to print the values. So then we come down here and we have a little look at what we're going to do. So we're always going to be reading the values every single line we go through the loop, which we're going through quite quickly. But once every second, we're going to print out the digital value, which will be a 0 or a 1. We'll take a little bit of space after it, and then we're going to print out the analog value, and we'll store the time. And to read the sensor, that is it. So, what I'm going to do is I'm going to upload this. I'm going to press the magic button, and we're going to hope it works, because it was working earlier, put it that way. So this will just go through its little bit. Connect that. There we go. Starting to upload. Now this is still going to work exactly as we had before. So I can do this. There, bring the servo to where you can see that as well. So yep, that works. Yeah. If I now bring up the serial monitor, which is up here somewhere. Now what you see there, the digital value is a 1, and it's reading the 4095 because it's not seeing anything. Now if I bring this, it's pointed a little bit. Oh, look at that, the value's changed. Put it directly above, pointed right at the thing, really drops. Move it away a little bit. Yeah, you're still getting a reading. What it's telling is the strength of this infrared light. Now if I put that about, say, there, this is up a little bit, there, a couple of inches. And if I then move my finger between the two, ooh, look at that. We've got a system. Now what this can do, depending on how far apart you put the things, it's called a beam sensor. It's a light beam. And there's a beam of infrared light going from that LED into the phototransistor. And the system is picking that up, and away we go. The board itself, if I angle this, you'll be able to see it a little bit better, has a second red LED on it. I'm trying to get this. It's behind these wires, rather, unfortunately. There's a second red LED that's not... no, sorry, a green LED that comes on when it sees light. That is the output of the comparator. As we'll see later, that's... sorry about knocking the camera there. That's not always what you want it to do. Now, the other thing to note is you've got sort of a viewing angle of where you can see this thing. It looks in a cone above itself. And that's that. And if, say, for example, that's all you need, you're just going to say, I need to read this value. I'm going to store it. I don't want to do anything with it. I'm just going to store it. Away you go. You can use the onboard comparator to give you a digital output. So you could, for example, have one of these set up and use that digital output directly to drive an LED with a suitable resistor. And you could say, well, I've got this thing sitting over here, maybe in a tunnel, say. Train comes along. Right, I know there's a train in that siding, even though I can't see it. You could use these for... say put the LED in a platform canopy looking down, because say you could be off to the side looking down, or you could have this in the platform side and you could have this in the other platform side underneath, and as a train comes along between them you detect it, and you can say when I detect this I want to stop. There you go, done. You've got a way of detecting it. Now there is another type of this sort of sensor that has the phototransistor and it's got an infrared LED mounted next to it, and that shoots a beam of light up. That detects something, it detects the light reflecting off it, and it comes back down again. Works in basically the same way. The problem with it is, I've seen a lot of people use them for detecting trains. I did try. The problem is the underneath of a train is black. Black is very good at absorbing infrared light. So you tend to find you end up having to paint a little bit of white or a little bit of silver or something on the underneath of a train for it to pick it up. It's not ideal. This, yes, you need a separate light source, but it works a lot better. But that's all we're doing with it there. Now, that's all well and good. I mean, it works, but I'm not doing anything with it. So what I want to do, I'm going to modify this, because at the moment this is doing nothing. I mean, I can do whatever I like with this thing, and it'll just carry on working exactly as it did in the relay example and the servo example. Let's add this in as another interlock, because that is potentially slightly more useful. So what we're going to do is we're going to come back up to the top. Now I'm going to add a completely new interlock into this. So we can see whether it's this button here that's triggering the yellow LED, which says the interlock is on, or something else. So what we're going to do is we're going to start up here where it says interlock false. I'm going to paste in a few more bits and pieces. Now you see me doing some typing, so I'm just going to do a bit of copy and pasting here, and we'll see how it goes. 3 more variables. So we have the sensor interlock. So we've got an interlock and we've now got the sensor interlock. Totally separate things. We've got last sensor interlock. This is because I want to be able to see if this has changed. Now, with the buttons, we're monitoring have the buttons changed, which is why we've got the last button state and so on flags down here. The interlock is an output of that. Here we're actually doing it a bit differently. We also got a threshold value. So if the sensor is reading above that, we're going to say the interlock needs to be on. Now, remember how this is working. At the moment, we can't see a train. When I put this here, it drops. So this is actually the exact opposite of the way you would actually want to do this. But it means I don't have to hold the LED above the thing the whole time to make it work. So that's why that's happening in that particular bit. And the other bit's going to stay pretty similar, but what we're going to do now is we're going to come down here and we've got this bit here that says, is the interlock false? We need to change that And we also need to say sensor interlock must also be false. And when we do that, this little thing here is a logical AND. So that's saying that this statement must be true and this statement must both be true to come into here. And if these, because we've got these, are they equal, are they false? If that's the case, both of our interlocks are clear. And you know what? If both our interlocks are clear, and we've said I want to change the thing to green, hey, yeah, fill your boots. Go for it. That'll work. That's not the only place we do that check. We also check that a little bit further down here. I'll come down here to see where I can find it. Where are we? Interlock false. We also need to change. I'll put the if statement back at the beginning. We also need to change that one there. And again, we're only going to do that if that's clear. But then we get into this one here where we're saying interlock error. Yeah, that's not strictly speaking true anymore. Because at this point, either of these or both of them could flag up. So what I'm actually going to do is replace that with this little bit of code here. So we know one or both is true, and we're going to say, well, if the interlock's in, we'll say that, and if the sensor interlocks in, we'll say that. That works. And again, we have to do that further down here as well. So that goes in. Note in both cases, if the interlock comes in, we're going to say the state is 1. The 1 is red, and we'll say it's changed. We have set that value. It could already be 1. We said we think it's changed, so we'll set that up as a change value. And that bit works. And what we're going to do is we come down here to where we've been doing our little bit of sensor reading, and I'm going to get rid... I want to get rid of that bit. No, we'll leave that bit. We'll leave that bit in. But in here, we're going to do a little bit of logic to start with. And what we're going to do is this. So again, I can just bring this in directly. We're going to say, is this analog value less than our threshold? Now, remember the comment I made a few minutes ago? Actually, what you're probably going to want to do in reality is say, is it above the threshold? This sensor is effectively, it produces a high output on its digital side when it can see things in a... Yeah, so... if you put the infrared light on it, it says, oh, I'll go 0. So, yeah, you can basically detect whether the light is there or detect the light isn't there. So, but if that's triggered, we're going to set the sensor interlock to be true. And then again, we're going to set the signal to be red. And if it's not true, we're going to set the sensor interlock to false. This does not latch. You could put a time delay in there. You could say, yeah, it must have been clear for a minimum amount of time before we can change it. But this just runs every single time. There's one more little detail we need to add in. What we need to do now, because at the moment this isn't going to do anything because we've not set this changed value. I can't put the changed value in here because if I do, every time we go through the loop, it's going to trigger. So this is where this little bit of code comes in here. So if it's changed, we'll set the value of changed. So if we came through on the last one, it's true. Next one, it's still true. That's not changed. So we only set this changed flag if the value has actually changed. And then we always just save what was it this time? So we've got the next time. And that should actually be it. So let's upload that and we'll see if it works. I'm hoping it does. Because if it doesn't, I've missed a line out that I need to add in somewhere. But we shall see. Let's have a little run on this. There we are, going with the upload. So that's run. It goes back to red to start with, as we've seen that. I'll clear the serial monitor and we'll run up there. This is still going to be reporting every second or so on here. So let's just check it works as normal. So we're not interlocked. So I can go to green. I can come back. I can manually set the interlock again with the button. Now nothing happens, but we get the interlock error warning. Turn that off, go back to green. Now I'm going to press the interlock, and that resets the signal to red and does whatever it was. Semaphore signal, whatever it is. Right. Okay, so let's bring this up. Now it's lit, but the light hasn't come on. This means I've missed something. So what have I missed? Let me just have a little look down here. Ah, yes, there's another piece of code I've missed out. Another line. All the way down here where we turn the LED on. The interlock does actually work at this point, but literally what's happening is the light isn't changing, which I need. So here it says if interlock. What I need to do there is say, it's not if the interlock is on, it's if the interlock or the sensor interlock. And this here is the logical or. So this will happen if that's true or that's true. Previously we had the and, where they both had to be. Here this is either. You could, if you wanted to, set the interlock so it only worked if both of them were true. But there we go. So let's just upload this again, and we shall see. Yes, that was why the light wasn't coming on. The interlock would have worked, but without the light, I'm not happy. I like lights. We're going to come to the screen video next time, and we'll see another way of redoing the status. So here, this comes up over here now. Point at that, and the yellow light comes on. The green light on the board, which you might be able to see down here flickering, also comes on. Now, I should be able to get, if I can get this to work. There, see, the green light's on, but not the yellow light. Come in a bit further. This is because my code threshold is a little bit different. So if I put that there, green button does nothing. Move it away. Green button works. Bring this back in. We flick back to red. And it doesn't matter if this comes in momentarily. It'll come back. This again, you might want to change a little bit of code that says, actually, this value, I'm going to debounce it, by which I mean it's got to stay at its value for a quarter of a second, maybe. But what we've also got is that can go on, turn the interlock on. Oh, it stays. Bring this back. Interlock comes off. Didn't register. There we are. So just make sure interlock on, goes away, interlock off. And it's actually holding the interlock on. Now the reason it's holding the interlock on, actually there is another little bit of code that needs tweaking. It's it can't release it while that's there, so it needs that tweaking a little bit as well. Not that big a deal at the moment, so I'm going to leave it at that. The purpose of this exercise was to show how to read these little sensors. So, why? I mean, I say you can get the board to do this value for you, which it does. I mean, suppose that little green LED does. So why would you do it with this analog system instead? Why wouldn't you just use the value that comes off here? Well, there are actually a couple of reasons why you might want to do that. And that's why these sensors are quite useful with a microcontroller. For example, if this was mounted under the board, and I've got 6 of these mounted under the board on Leopard Street now, getting at this variable resistor can be a little bit tricky. I mean, you can do it, but a little bit tricky to set up. You say, but I'm not using that at the moment. I mean, yes, we've got the digital output. This is what the 1 or the 0 at the beginning of the serial monitor is. So we can see it. But maybe it's easier to set a value in code. Maybe also you need to adjust it and you might need to calibrate it a little bit. It's just a little bit awkward. I mean, if you're under a board, for one thing, you tend not to be able to see what's actually going on, although you do helpfully have the little green light there. It might be easier to do it elsewhere. If you're using an ESP where you've got Wi-Fi connectivity, which is something else we'll have to look at in future, you can adjust it remotely quite easily. But also there's another thing, and this affects the little sensors that also have the LED next to it. What if you run your layout during the day and at night? What happens then? You've got different light levels. You might have a level of infrared light during the day, depending on how you're lighting the room up. If you've got incandescent lights, for example, you've got some infrared light. These sensors will pick that up. Yeah, maybe that's a bit of a problem. What you can actually do is have one of these, literally like this, just mounted somewhere on the layout, put it in a chimney or something, pointing straight upwards. And what it's going to do is measure the ambient light level, and you can read that in here, and you can say, I'm going to adjust that threshold number that we had up at the top based on what this sensor is telling me about my room. So you can compare one to the other. And that's it's just something else you can do with these things. Now, these things do make for very good train detectors. Leopard Street uses block current sensing. It's a DCC layout. It can use block current sensing. This, you may notice there is a complete absence of a model railway here. These things just work. This will detect wagons. Now I'm going to be using this as the entrance to my reversing loops. This is the little project I'm building up to. Because it needs these sensors. It needs relays. It doesn't need the buttons. It does want some LEDs. It's not going to be controlling a servo because it doesn't need to. It's just literally going to be controlling a reversing loop relays. But these will detect anything. Coaches, wagons, guards, vans, cats wandering past, just about anything really. So I'm using them in an offstage area where I can mount the infrared LED above it. Like I say, you've got to hide it a little bit elsewhere. But other things you can do, I mean, this will tell you a train is at a specific point instead of at a block. So anything that needs to know the train is at a specific point. For example, if you've got a level crossing, you could use one of these things to trigger the sequence to close the gates as a train approaches from a specific point without having to mess around with, I want a special little detecting block. You could use them on station bay platforms and terminal platforms to tell you this train is now at the end of the platform. So say you've got the locomotive at the back pushing the coaches in, might not trigger a block detector. It'll trigger one of these. So yeah, lots of little ways you can do these things. They are fairly simple to use. Now the same technique, I mean this is an infrared light sensor. You can use the same technique with, for example, a light dependent resistor. You set that up, you wire it up, and you can measure the voltage it's putting out. And you can use that in the same way. You could decide what you're going to do with that. In fact, any sensor that produces an analog output, there are Hall effect sensors that detect the presence of magnets. And you can use those. Some of them, again, will have a little threshold trigger on them. Some of them you just read the strength of the magnetic field, and it's up to you what you want to do with that. Electrical current sensors, they work in a very similar way. You can, it will give you a voltage that you need to measure. See what I mean about you can see the LED, purpley glow there. This technique can be used to measure anything. You can, for example, you could put a rotary potentiometer that you can twiddle, read the value. Oh, you could use that to control the speed of something. This analog read function is very, very useful. So, yeah, that's the latest addition. So, just to conclude, in this episode we've seen two things. The first is how to use this infrared sensor to, well, sense infrared light. Both as a sort of analog, how much light is there, is it above a threshold, is it not, and do something with that information. And secondly, how to just read the digital version, which I could quite easily have used that as well. So I say there's plenty of other bits and pieces on this. Now, the next episode, I promise I will look at this screen. I did think about it for this one as well with, I could put the number on there, the reading from the sensor. I've held off because screens are a bit of a topic all on their own, so we shall see in that. Anyway, that's going to be it for this episode. Hopefully you found that moderately useful, and you may be sort of thinking of the various little things you can do. This is key, you don't need the ESP32s. An Arduino Nano will read quite nicely. This thing can can read on a lot more pins. The Arduinos don't have as many and they're not as accurate, but something like this, they're probably fine. But with that, I shall leave you for the rest of your day. I hope you enjoy your day. As usual, likes, comments, shares, etc. are very, very welcome. The channel is now at over 850 subscribers, and yes, thank you all so very, very much. Until the next one, it's goodbye from me, and I will just leave you with well, playing, basically. I love sensors. I love messing around with them. There's all sorts of things you can get. You get temperature sensors, distance sensors, laser sensors. Yeah, it's brilliant. Anyway, goodbye for now.